Okay, we're here with about monomials, the least common multiple, and greatest common factor. That's a lot of words. You ready for this, Jordan?
Yeah.
Okay, so we'll talk about what a monomial is in a second, but let's review these other things first, because you probably have heard of these, and every now and then if you spend a little bit too much time in the summer or not thinking about these, then you forget what least common multiple and greatest common factor are. So let's look at those first. Okay, so the least common multiple, okay, it's the lowest integer that two integers can divide into evenly. So that's a lot more words. Let's look at an example. This is usually makes it clear for me. Okay, and least common multiple we can call LCM. Okay, so the least common multiple of 3 and 4 is 12. Now let's figure out why that's true. 3 has multiples of 3, 6, 9, 12, 15, 18, right?
Yeah.
Okay, and then 4 has multiples of 4, 8, 12, 16, 20, right? Mm-hmm. Okay, so they have a common multiple, and that's 12, because when I was listing that out, there was a 12 in both of those, right?
Right.
And it's also the least multiple that they have in common. There's not a lower number that both 3 and 4 can divide into. Do you see that?
Yeah.
Okay, so that's why we call it the least common multiple. Now, there are other common multiples they have, like they both divide into 24, for instance. 3 times 8 is 24, 4 times 6 is 24, but that's not the least one. So when we look for the least one, we have to find that. In this case, it's 12. So now let's do another example. What's the least common multiple of 2 and 9?
18.
Good, it's 18. And you did that really quickly. What did you do in your head to get that?
I multiplied 2 and 9.
Good. And oftentimes, that's what you do, because 3 times 4 is 12, right?
Right.
And 2 times 9 is the least common multiple, which is 18. Sometimes, though, you'll have an LCM that's not the two numbers multiplied by each other. So let's look at an example. Can you figure this one out? What's the least common multiple of 5 and 15?
15.
Yeah, exactly right. That's good, because 5 divides into 15, 5, 10, 15, 20, 20. And 15 also, of course, divides into 15, 15, 30, 45. So the least common multiple isn't 5 times 15, which would be 75. It's actually a much lower number, and that's 15. Good job. Okay, now, why should you even care about least common multiple? Well, it makes things like adding fractions easier is one reason. So let's say you had 1/5 plus 1/15. Well, you would make that into 3/15 plus 1/15, and then you'd add those and get 4/15. Does that kind of make sense?
Yeah.
Yeah. So you wouldn't want to do that with 75. You wouldn't want to say, okay, 15 75ths plus 5 75ths is 20 75ths. Now I've got to simplify that fraction. You want to use your least common multiple. That's why you want to use that. Make sense?
Yeah.
Okay. Now, that's LCM. Let's talk about greatest common factor. Okay, so this is another definition here. Let's take a look. The greatest integer that is a factor of two integers. Okay? So we're not going to be finding a multiple, but we're going to be looking for factors. So let's take a look at an example here. So the greatest common factor of 12 and 16. So it's the biggest number that divides into 12 and 16. So you could say, well, 1 divides into 12 and 16, and 2 divides into 12 and 16, right?
Right.
But those aren't the greatest ones. The greatest one is 4 that divides into 12 and 16. Make sense?
Yeah.
Okay, let's do another one really quick. So what's the greatest common factor of 36 and 24?
12.
Yeah, that's excellent. So that one you can probably remember from your times tables, because your times tables go up to 12. But this one was tricky because, 2 divides into both of them, 3 divides into both of them, 6 divides into both of them. You could have gotten a lot of other ones, but the greatest one is 12. Now, why should you care about this? Well, it makes other things easier, like let's say simplifying fractions. If you had 24 36ths, you wouldn't want to divide both of those two and say, okay, that's the same as 12 18ths. Oh, wait, I can simplify it further and divide those by 2. Oh, that's the same as 6 ninths. You can see even I'm messing up right now. What you want to do is divide them just one time by the greatest common factor. And in that case, it would be 2/3. So That's how it works with numbers. Now let's talk about what a monomial is. So let's look at this definition up here. A monomial is a single term, and it may include numbers and variables. So let's look at an example. That's 3xy to the fourth. That's a monomial because it's just one term. It's not two things added or subtracted from one another. It's just one single term. This 5t plus 7g, that's not a monomial because it has two terms. Make sense?
Yeah.
Okay, so we're going to be working with monomials, and we're going to try to find the least common multiple and the greatest common factor. Let's first look at the LCM. Okay, let's do an example. So we have 3t and 4t squared, and we have to find something that both of these will divide into. Just like over here, we needed to find something that 3 and 4 would both divide into. Well, that's a little bit of a clue on this one because this is 3 and this is 4. And the least common multiple is 12, but then the t and the t squared both have to divide into it. If we just put a t right there, t squared can't divide into t. So you need something at least as big as the t squared. So does that kind of make sense?
Yeah.
Okay, so one of the ways we can think about this is the steps you take, the strategy. So first you can find the least common multiple of the number portion of the terms, like the 3 and the 4. And then you can find the least common multiple of the variable portion. And then you can combine them back into that single term of 12t squared. Okay, so let's do another example here. We have 2ab and then 9a cubed b, and we want to find the least common multiple. So what's the least common multiple of the 2 and the 9?
18.
18, good. And that was just like this example that we did over here. Now, how about that ab and the a cubed b? What do you think the least common multiple of that portion would be?
A cubed b.
That's exactly right. It's a cubed b, because you need something that both ab can divide into, which it can divide into a cubed b, and that a cubed b can divide into, which of course it can divide into a cubed b. So the least common multiple of the number portion, 18, of the variable portion, a cubed b, then you recombine it, and the least common multiple is 18 a cubed b. Make sense?
Yeah.
Okay. Now let's switch our minds to greatest common factor, just like we did over there with numbers. Okay, so now what we want to do is we want to find the factors. So we're looking for something that divides into like 12 and 16, and we put the same thing over here, but also has to divide into t and t squared. Okay, so let's go ahead and figure out what that is first, and then we'll figure out how we got it. So the greatest common factor, 4t, will divide into 12t 3 times, and into 16t 4t times. And so it's the greatest one that will go in. And the way that we figured that out was very similar to our strategy for LCM. First, we find the greatest common factor of the number portion of the terms. In this case, that's 4. And then we find the greatest common factor of the variable portion, and that's t, because there's not a greater factor that can divide into t and t squared. Does that make sense?
Yeah.
Okay, great. So you can find these, and then you can do things like why you should care over here. You can add fractions with monomials in them instead of just integers, and you can also simplify fractions with monomials in them, as well as factor and do a bunch of other stuff now that you know how to do LCM and GCF with monomials. Good job.